Greetings, fellow Meccas. Today, we'll be working on an independence axiom problem. What is independence axiom? Well, it's the preference between two options that should not change when altering both options equally by mixing them with a common gamble. The problem. Consider the following lotteries. Lottery 1. A with probability 1/4, B with probability 3/4. Lottery 2. C with probability 1/4, D with probability 1/4, B with probability 1/2. Lottery 3. A with probability 1/6, B with probability 1/6, D with probability 2/3. Lottery 4. C with probability 1/6, D with probability 5/6. Show that to be consistent with the independence axiom, if 1 is chosen over 2, then 3 should be chosen over 4. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you were able to solve this problem. Now let's work on it together. So we need to show that to be consistent with the independence axiom, if 1 is chosen over 2, then 3 should be chosen over 4. So let's first write out our lotteries. So lottery 1, we have A with the probability 1/4 and B with probability 3/4. So, and we have 2, lottery 2, which is C with the probability of 1/4, D with the probability of 1/4, and B with the probability of 1/2. Now how can we rewrite this so both lotteries are equal, all the same? Well, we can do this by rewriting number 1. So we rewrite the first lottery as B to the 1/2, 1/2 here. So each point, the lines, they need to equal to 1. So then if we draw this right here, this also needs to equal to 1. So what can we do? Well, we can say A to the 1/2 and B to the 1/2. And this rewritten lottery needs to equal the one above. Which, how do we check that? Well, for here, B is 1/2. So now we need to get 1/4. Well, we take this 1/2 times this by B times 1/2, which is 1/4. If we add that to the B on the left-hand side, we get 3/4, so it remains the same. A needs to remain at 1/4. So 1/2 times 1/2 is 1/4, so A also remains the same. So we have rewritten this lottery successfully from the original lottery. Now we need to do the same thing for the second lottery. So we can say B is 1/2. Bring this down to 1/2. And then we have C is 1/2 and D is 1/2. Now we need to check to make sure this one also is the same as the original lottery. So we get 1/2 B, correct. Now we need to check C, which is 1/4. 1/2 times 1/2 is a 4th. And D, 1/2 times 1/2 is the 4th. So as you see, lottery 1 and lottery 2, both rewritten from the original lotteries, are the same. So we can see that if one can be chosen over 2 in this case. So now we need to do the same thing for lotteries 3 and 4. So for lottery 3, the original lottery was 1/6 for A, 1/6 for B, and 2/3 for D. 1/6, 1/6, 2/3, A, B, D. And then for the fourth lottery, we had C 1/6 and D 5/6. C, D 1/6, 5/6. And now we need to rewrite both of these so we get the same rewritten lottery. So for the third lottery, we can rewrite this as 2/3 D, and then we can say 1/3, then make another branch down. We get 1/2, 1/2, A and B. So if we check to make sure this is the same, 1/3 times 1/2 is 1/6 for B, and 1/3 times 1/2 is 1/6 for A, and D is 2/3, so that it all remains the same. Now for 4, this needs to be the same. So if we do 2/3 for D, 1/3, 1/2, 1/2, C, D. And we can see that 2/3 plus 1/3 times 1/2 is 1/6. So we get 2/3 plus 1/6, 6, 4, get the same common denominator. So we can add them together. We get 5/6, which is D, so that's good. And then 1/3 times 1/2 is 1/6 for C. So this all makes sense. This all is the same. Therefore, if we use the independence axiom, if 1 is chosen over 2, then 3 should be chosen over 4. We have proven that the lotteries rewritten all the same. So if we're using the independence axiom, 3 is chosen over 4 if 1 is chosen over 2. And that is the solution to the problem. I hope this video helped. If it did, please consider subscribing and liking this video. Thank you.